In this video, I'm intending to show you how to find the determinant of a 3x3 matrix by hand. So, I suppose I could take a formulaic approach to this, A, B, C, D, E, F, G, H, I. If you want to find the determinant of this, I'm definitely not gonna give you a formula for this because it would just be a disaster. The idea that we use here is something called expansion by minors. And you don't actually need to know the phrase expansion by minors, but I figure it's worth mentioning. The idea is you are going to sort of break this down into smaller matrices. The determinant of this 3x3 matrix will be A, which is this first guy here, times the determinant of a smaller matrix. And the way it works is imagine that you threw away the column and the row that A were in. If you were to get rid of all of these, what little matrix would be left? The little matrix that's left would be EFHI. EFHI. So that's the first part of your determinant. Then you do minus, always minus, 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 minus the next one, B. Right? So B is the next one across. So first I picked A from here. Then I might as well use a different color. Let's say we're going to use red for B. So I'm picking B here. Now imagine that I threw away the column and the row that B were in. So if I were to throw all of this away, what mini matrix would be left? Well, you'd have D, F, G, I. So we're going to do D, F, G, I. And then finally, we'll do plus C times the determinant of a mini matrix. And again, imagine that you threw away the row and the column that C were in. If you got rid of all of this, the mini matrix left would be D, E, G, H. So D, E, G, H. So to find the determinant of this whole thing, we now need to go back and find the determinant of this thing and multiply it by A, find the determinant of this, multiply it by B, find the determinant of this, and multiply it by C. So as you can imagine, I could write out a horrific formula here, but I don't want to do it. We might as well just get to some examples of problems that use real numbers and do a real example of this. The big thing to remember is that you look at the signs. A keeps its sign, B changes its sign because there's a minus there, and C keeps its sign because it's plus. And that's always the way this is going to work. So I'm going to get into my first of two examples. So I want us to find the determinant of this matrix. Right? So just like I said before, I feel like it might be helpful for you to start by saying, okay, it's going to be 1 times the determinant of some mini matrix minus negative 3 times the determinant of another mini matrix. Then plus negative 2 times the determinant of another mini matrix. I should be calling them the associated minor, but mini matrix. It's mini matrix. Just sounds cuter. So this is the setup. I hope you guys understand where that came from. If you don't, look at it again. All I can say is you basically take this top row, you take the first number, you take minus the second number, plus the third number, and then we need the minors associated with them. And this is where I want you guys to pause the video and fill in those blanks. Make sure you know what's supposed to go there. Okay? So for the 1, it's supposed to be 0, 1, 1, negative 1. For the 3, it's supposed to be 2, 1, 5, negative 1. And for the negative 2, it's supposed to be 2, 0, 5, 1. So now the last part of this process is that we just go through and figure out what each of these individual little determinants is. So you've got 1 times, this one here will be 0 minus 1, so negative 1, plus 3 times negative 2 minus 5, that's negative 7, minus 2 times 2 minus 0, so it'll be 2. So negative 1 minus 21 minus 4. It looks like we're seeing a determinant here of negative 26. Yay, we win. The determinant's negative 26. Remember what we use the determinant for. Its only purpose is to tell us whether the inverse exists. And the idea is, if the determinant is not 0, the matrix has an inverse. If the determinant is 0, it doesn't have an inverse, and it's something called a singular matrix. So I hope you guys remember that. To be honest, we're going to use that in the next example. So here's this last example. Find the value of the constant A such that the matrix B, given below, is singular. So remember what singular means, and I just said it like 10 seconds ago. Singular means it has no inverse, and the way that we show that is by showing that the determinant of the matrix we're looking at is 0. Right? So what I want you guys to do is I want you to set up the expression for the determinant. Like, what number goes first, what is the associated minor, and then what comes next, Like, basically what was our first step from the previous problem. So set it up, and then unpause the video, and make sure you got your setup right, and then we'll compute it, and we'll work through the rest of it. So your setup should be that you've got 3 times its associated minor, which is 1, negative 3, 2, 3. Then you're going to have minus, because it's always minus. Then the second number, 2, times its associated minor, which is a, negative 3, negative 2, 3. And then finally we'll have plus negative 1 times its associated minor, which is a, 1, negative 2, 2. And the idea is supposed to be that this entire thing is equal to 0. And I know that because I need the determinant to be 0 in order for this thing to be singular. It's my only hope. Right? So now that we have this, like, I know it looks complicated, but the reality is if I just do this determinant, do this one, set it equal to 0, it should not be difficult for us to solve for A. And so now I'm going to ask you guys, pause the video, work through that on your own, and then check your answer with me. So here I've got 0 equals, so let's see, it's going to be 3 times, let's see here, 3 minus a negative 6, so that's 9, minus 2 times 3a minus 6, and then minus 1 times 2a minus negative 2, so plus 2. So 0 equals 18 minus 6a plus 12 minus 2a minus 2. This is 18. I guess I could have put those numbers together. Yeah, okay, 18. Put these together at least. Minus 8a plus 12 minus 2. So these make 30. Minus 2 is 28 minus 8a. And we're almost there. 8a equals 28. Dividing by 8 gets us a is 28 over 8, which can simplify down to 7 over 2. And apparently that's the value of A that makes that matrix singular. That's the one and only value of A that makes our original B matrix not have an inverse. Okay, and that's the end of finding determinants of 3 by 3 matrices. If you've got that, then you've got the hang of it, and you're ready for the assignment. So good luck with that.